Hello, I would like to show you today how to build a multiplexer using Logisim and this multiplexer circuit is based on the following rules. I have two inputs, A and B. I will add them right now. So one is A, is an input, and the label is A. Then I will have another input for which the label is B, and I have a third input which is a selection, another pin right in here, and I will put it cell, and depending on the value of the selection, the circuit will output the values that are taken by A or the values taken by B. Let me add a fourth pin, which is the output. I have to change the orientation, then it should be an output, and Mux output. I will put it like this. So we have to build this circuit. The rules for it are in this table. So I have A0, B0. If the selection is 0, it will take the value of A. Whatever A it is will be put in here, returned. If A is 0 and B is 1, and the selection is 0, then again it will return the value of A, which is 0. In the case of 1, 0 and 1, 1, the values will be 1 and 1 because the selection bit is 0. If the selection bit is 1, it should return whatever values are coming from the B input. So if I have in here 0 and 0, because B is 0 and selection 1, 0 will be returned. 0, 1 in here, because B is 1 and selection 1, it will return 1, and the same in here. If this is 0, it returns 0. If this is 1, it returns 1, and the values of A doesn't matter if the selection is 1, and the values of B doesn't matter if the selection is 0. In order to build this circuit, the regular way of doing it is to look at the lines which return 1. So I have this situation in here, this line in here, then I have this line in here, and this one. The regular way of doing it is to have check what kind of input I have in order to get 1. So A should be 1, not B should be 1 because B is 0, not selection should be 1. And then I have a second row for the case where I wish to return the value of A, a second row which is A1, B1, and not selection is 1 because the selection is 0. And I put it in here, the expression only for A. So the Mux value will return the value of A. If A is true and not being true is true and not selection is true, or I've made a mistake in here, I have to put it like this, or A is true, B is true, and not selection is true. in order to simplify this logical expression, I will apply some transformation. First of all, will use commutativity for these two expression and for this pair, in order to have A and not cell and not B, or A and not cell and B. Now I see that I have in here A and not cell, and in here I have A and not cell, and I apply the distributivity laws in reverse, and I get this A and not cell and not B or B. Because not B or B is always true, I mean B can be or false or true, and this expression will always return true. I have in here a tautology, then I have A and not cell and true, and if one member of an AND operation is true, then the result takes the value of the other member. And because this member is always true, the result of this expression is given by whatever A and not cell has as value. So this is the expression for the case where A is returned. And the same we do with these two these two rows in here. So I have one, let's put it like this, and I have another row in here, let's put it like this. So I do exactly the same thing with these two rows, and I will have an expression B and cell. So the final expression is A and not cell, or B and cell. Let's build the logical circuit using regular gates that we have in here in Logisim. So first of all, I will add a NOT gate, because I need to have the selection negated in order to have the case where A is returned. Then I will have to put it in relation with A through an AND operation. I will go like this and then like this. For B, I will have to use the value of cell as it is and the value of B as we have in here. So I will add another AND gate, and I will put it like this, and then let's say like this, and I have an OR in here to connect the result of the left and right expression. So I will go to an OR gate. Maybe it's too crowded, but still it does the job. And I will connect this one in here and this one in here, like this. Right now we will be able to check if the circuit is working. Let's go to here, and what I know is that when selection is 0, then whatever I have in A, it should be returned in here. If I click on A0 and this one is 0, if I go like this, it will become 1. If I make it 0, it will become 0, and so on. So I click on it many times, it's exactly the same value. If I keep it as a value at the value 1 and start to modify b, nothing will happen. Changes in the value of b won't be taken into account. Right now, let's change the value of the cell bit to 1. Based on the logic that we've just built, it should take into account the value of b and not to look anymore of whatever value I have in a. I'm going and put selection 1. Now b is 0 and the output became 0 even if a is 1. And now if I click like this on b, what I see is that the values of b are reflected into the output, and whatever value I have in a, it will not be taken into account. So this is the behavior of a multiplexer, and this circuit is also available as a predefined circuit in Logisim. If I go, how should I do? If I go in here, okay, so if I do, I will add a pin, I will not give it a name, like this. Then I will add another pin to make it faster, like this. And now if I go in here and I will go to top and right, like this, and I will add another pin and change the orientation to the north, to the south, sorry. So this is a selection pin. Let me, I will put it cell pre-def, or cell 2 to make it shorter, and I will put it in here A2, and in here I will put B2, and I will add also an output pin like this, change the orientation, make it output and connect it like this, and let's see how it behaves. If the selection is 0, the value of A2 should be reflected. I have a small 0 in here. Maybe it's not, I have to increase the size. And now you see a small 0. Let's check the behavior. If I go to B and I change it, nothing happens, because selection is 0 and this is the pin which will be outputted if the selection is 0. If I go to A, that's it. Because the selection is 0, A will be taken into account. If right now I do selection to 1, the value of B2 will be taken into account and the output will become 0. And it becomes 0, and I'm changing the output reflects the values of B2, and whatever I have in A, it will not be taken into account. That is all for today, and thank you for listening.